Alright, in this video we are going to talk about kinematics, and I'm going to do a couple of past paper questions for you guys of this particular topic. And again, what I've done here is I have highlighted the key concepts that are frequently tested in this topic, and I'm going to go over every single one of them. Not in great detail, but we're just gonna skim through it, okay? And then when we're doing past paper questions, that I would like to do in great detail. And again, this is a document that I have compiled for you guys. It contains notes from my online classes, and some of it I've added a couple of things such as the key concepts over here, and I've added these key points. I've refined them slightly. Make sure that you go through them, and if you do go through them well, then I can say for sure, not guarantee, but say for sure that you will be able to do uh, pretty much all the past paper questions with ease. I don't like making big claims that this is all you need to know about kinematics, but yeah, this will definitely help you. Um, Whatever it is, whatever your status is in kinematics right now, this will definitely bring it up. Okay. And again, if you practice well enough, if you do enough past paper questions, then of course I can guarantee that you're gonna be in the green zone. Okay, so let's go over them one by one. So kinematics is basically the study of a particle moving in a straight line. That's what it is in essence. Now, over here we're going to be dealing with differentiation. And when exactly are we going to be dealing with differentiation? So you'll be given displacement. Displacement, by the way, is the shortest distance from the starting point. Okay, and again, I've explained that in these notes over here, so make sure to go over them, and this will inshallah help you understand all these things in detail. So as I was saying, displacement is basically the distance from the starting point, and you differentiate displacement to get velocity or speed. And the only difference between velocity and speed is that velocity tells us the direction, whereas speed is always positive. Velocity can be negative and positive, and of course, it being negative positive basically means the idea of it being negative positive is so that we know exactly what direction the object is headed in. And then we have velocity, which we differentiate with respect to time, again, to get acceleration. So that's one thing. These are the areas where we will be using differentiation. So make sure that your differentiation is on point. Differentiation of trigonometric functions, exponential functions, algebraic functions, composite functions, and what else do you have? I hope I haven't missed anything. Logarithmic functions, I think I mentioned that. But anyway, then you're going to be dealing with integration. So if you know your differentiation, I'm hoping that you know your integration also. So basically, you're going to be integrating acceleration to get velocity, because you differentiate velocity to get acceleration. And then you're going to be integrating velocity to get the displacement or distance. If you remember from math, we would calculate the area under a speed time graph to get the distance traveled, and that's one of the many uses of integration to calculate the area under the graph. So if you calculate the area under a velocity time graph, you basically get distance traveled. Okay, and then you're going to be asked to find the distance. So you could be asked to find the distance at a particular time. Okay, you could be asked to find the distance traveled between two values of time, like for example from t is equals to 2 to t is equals to 4, or from 3 to 5, or you may be asked to calculate the total distance, or in some cases you may be asked to calculate the distance from the starting point. Okay, and then a couple of things that I want to point out is that whenever you're asked to find the maximum velocity, okay, we will come across questions where we'll have to find maximum velocity or maximum speed. Remember, when an object is traveling at its maximum velocity, there is no acceleration. So that means acceleration is 0. And the reason behind that is because acceleration in theory is the rate of change of velocity or the rate of change of speed. So if you're traveling at a maximum velocity, or if you're traveling at constant velocity, doesn't matter whether it's maximum or not, there is no change in velocity, that means acceleration is 0. So that's one thing you got to remember. And there will be a point where the question will ask you to calculate the time when the object is instantaneously at rest. So whenever an object is at rest, whether it's instantaneously or whether it's just at rest, we plug in velocity as 0, and then we work out the value of t, or whatever it is that we have to work out. And then you're going to be asked to convert graphs. So you may be asked to convert a velocity time graph into a displacement or distance time graph. And then you may be asked to convert a velocity time graph into acceleration time, and the other way around also. Okay. Now a couple of key points that I'd like to go over one by one. So distance from the starting point O is called displacement. So when an object, and here's key point number 2, when an object starts from O, at t equals to 0, its displacement is also equal to 0, because that means it's at the starting point, so its distance from the starting point is 0. And again, the derivative of displacement with respect to time is velocity. The derivative of velocity with respect to time is acceleration, and here I've just sort of summarized this for you guys. And again, at maximum displacement, velocity equals to 0. So this is something that you can think of this way, that if you throw a ball up in the air, the maximum displacement just before when it starts to come down, for a fraction of a second, it's 0. Okay, if you were to look at it in slow-mo, you'll know what I'm talking about, but it's not a very difficult thing to wrap your head around. If you throw a ball up, so before it starts to come down, it just pauses for a fraction of a second. So that is the point where its displacement is maximum, and that is the point where its velocity is equals to 0. And then at the turning point, so whenever an object is headed in a straight line and then it comes back, so before it can do that, it has to turn, okay? And when it turns, the velocity is equal to 0, okay? So this works the other way around also, that whenever the velocity is equals to 0 in, let's say, during a certain period of time, if the velocity is equal to 0 at a certain instant, we kind of make the assumption that the object has turned. And again, we'll be dealing with this in a couple of past paper questions, and then you will understand exactly what I'm trying to say here. And then again, instantaneous t at rest, velocity equals to 0. I already mentioned that above. And then initial displacement, initial velocity, initial acceleration. Whenever you're asked to find any one of these three, you got to remember that for these three, time is equals to 0 seconds. And then when an object is back to the starting point, its displacement is equals to 0 at maximum velocity. I just pointed out maximum velocity. At maximum velocity, acceleration is 0 meter per second square. Area under velocity time graph gives distance, like I mentioned. In some cases, it also gives you displacement, but we'll sort of learn to make the distinction when we're dealing with actual questions. And then if area is negative, it means it has gone beyond the starting point. So that means if the area is minus, let's say 20 meters, that means the object has gone 20 meters beyond the starting point. So if it started at O, so it has gone to 20 meters towards the left side of O, okay? That is, if you take the right side positive, then it left will be negative. And then gradient of distance time graph gives you speed or velocity, so distance or displacement time graph. Displacement is basically distance, it's just another form of distance, okay? So yeah, and negative velocity means that the object is traveling in the opposite direction. So for example, if you're going from your home to school, so your velocity, let's say, is positive 20, but if you're coming back, so in that case, since you're going in the opposite direction now, so whatever the velocity is, as far as velocity is concerned, we're going to call it negative, okay? And then it says negative velocity means, okay, I just read that. Gradient of speed time graph gives acceleration, and one thing I should mention is that negative gradient of a speed time graph basically represents deceleration. That means that the object is slowing down. So I'll write that before uploading and sharing this document with you guys. You'll find this document in the description box. Make sure to download it and share it with your friends or whoever you think can benefit from it. And again, here are a couple of questions. Like I mentioned in the beginning, that these are basically notes from my online class from May June 2021. Yeah, so not last year, this year actually. Never mind. Anyway. So let's get straight to work. Let's get to the purpose of making this video, which is doing a couple of past paper questions with you guys in detail so that you guys know exactly what I'm talking about. So these are the past paper questions, and just to run you guys through what I have here. So again, as you can see, I have highlighted every single part of, not every single, there are some questions that really don't fall into the concepts that I've mentioned, okay? Some one-off questions. So what I've tried to do here is I've highlight every single part, most of the parts with a certain color, which is basically referring to what concept is being tested in this particular question, okay? So yeah, and that was just the intro, and now we're gonna get to some past paper questions which I would like to solve with you guys in detail. So let's start. Okay, so now I have a question from October-November 2020, paper 1, variant 3, and this is question number 4 of that particular paper. So let's see what it says here. And before I start, you can see that I've highlighted it gray, which basically means that this is a question that's dealing with conversion of graphs, or just using graphs. Okay, so it says here, on the axes below, draw the velocity time graph for the runner. Okay, so before that, let's see what it says. The diagram shows the x to t, which basically means that x is displacement, as it just further elaborates, in meters, and t is time, which is measured in seconds. Okay, on the graph below, draw the velocity time graph for the runner. Okay, so let's do just that. So let's have a look at the first part of the question. So first part of the graph, sorry. So this is the first part of the graph that I'm highlighting for you guys. So we're looking at a displacement time graph. Okay, so gradient of displacement time graph, remember, gives you what? Gives you speed. Okay, so what basically that means that we need two values. So let's have a look at from these lines so that we can work out the gradient. Okay, just like simple coordinate geometry. So here's one point, 2 points, sorry, I said two values, I basically meant 2 points. So here's one point which has coordinates 50, 100, and again and the other is going to be the origin, which is always your safest bet. So if I work out the gradient of this, so it's going to be 100 minus 0 over 50 minus 0, which means it's equal to 100 upon 50, which basically means it's equal to 2. Now, up until 50 seconds, the velocity was constant. Okay, so we have a constant sloping line, which means that the gradient is fixed at 2, which basically means that the velocity is equal to 2 meters per second. Okay, so I'm gonna try and color code this for you guys also. So let me delete this. Yeah, so this, in fact, let me highlight this in green for you guys so you know exactly what I'm talking about. Yeah, and then we're gonna make a horizontal line at 2 meters per second, which is gonna go up until t is equals to 50. There you go. And then you have a horizontal line. Now remember, in a displacement time graph, horizontal line basically means that the velocity or speed, whatever, is equal to 0. Now why is that? Let's have a look. So when your line is horizontal in a displacement time graph, that means time is passing, which it will always, but there is no change in distance. So the distance is fixed at 100. Now when exactly does that happen? That happens when you're stationary or when you're at rest, like I am right now. Okay, time is passing, but I'm not going anywhere. That means my distance from whatever the starting point I take it to be as is going to be the same. Okay, so that is why the speed is going to be 0. So there's no need to show that on the graph, okay, because it's just going to be on top of the x-axis, so we can ignore that. Then, however, we have this part of the graph. So again, I'm going to try and color code it for you guys, which I'm highlighting in red, and this goes from 65 to 85, and during this time at 65 the speed is equals to 100. So let's write that down, 65 comma 100, and then at this point the speed is 85 comma 150. I mean, the time is 85, the speed is 150. So I can very conveniently work out the gradient. So I'm going to do just that. So I'm looking at 150 minus 100, y2 minus y1 upon x2 minus x1. So that means 85 minus 65. So we're looking at 50 upon 20, which basically means 2.5. Okay, so speed has slightly increased, and it has increased by 0.5, although we don't really need to mention that, but just to be on the safe side, I'm going to work this out in my calculator. So 150 minus 100 is 50, and then divided by 85 minus 65. So okay, so 5.2, which is 2.5. Okay, now from 65 to 85 the speed is 2.5. So that's exactly what I need to show. 65 to 85, you can see that the speed is 2.5 meters per second. Okay, and then the object is coming down. So instantly that should tell you that this means that our velocity is going to be negative. Okay, so again, I'm going to try and color code this for you guys. So and I just realized that I didn't color code this, so I'm just going to turn this to red so you know exactly what I'm talking about. Okay, now coming back, this is the part that I'm highlighting blue for you guys, and again I need 2 points so that I can work out the gradient, which will basically be the velocity. So I already have 1 point, 85, 150. The other point, however, is going to be 125 comma 0. So let's work out the gradient. So that's going to be 150 minus 0 over 85 minus 125. Okay, y2 minus y1 upon x2 minus x1. So we're looking at 150 minus 0, which is 150, and then in the denominator we have 85 minus 125, which is equal to minus 3.75. Okay, so you got to be careful with the 75 thing. So minus 3.75 means it's going to be between minus 3.5 and minus 4. And this is from 85 all the way to 125. So between minus 3.5 and minus 4, we have a negative velocity. We have a velocity of minus 3.75 from 85 to 125. Okay. And then, let me just color code this. Okay. So there you go. This is what our final answer is. So let's have a quick recap of this. So our So our journey is basically divided into a total of 4 parts. Okay, one is the green one, where the object is traveling at a constant velocity of 2 meters per second. So we showed that on the graph. It's doing that from 0 to 50. And then 50 to 65, it's not moving at all because the distance doesn't change. That means the speed is 0. And then from 65 to 85, the speed is fixed again at 2.5. How did we work that out? We worked that out by calculating the gradient. And then from 85 to 150, since it's coming down, that means it has turned. That means it is traveling in the opposite direction, which basically means that our velocity is going to be negative. And we worked it out with the help of the gradient again. So 150 minus 0 over 85 minus 125. So that gave us minus 3.75, which we showed on the graph. Minus 3.75, remember, is going to be between minus 3.5 and minus 4. Okay, so that's that. We get our 3 marks for these 3 different lines, and we've gotten them, and there you go. Then it says find the total distance covered by the runner in 125 seconds. So again, we're using the graph to work something out, and let's find out that what exactly are we trying to find out. So remember that distance is basically area under the graph. Okay. Now there are 2 ways that we can work this out. Okay. We can use our displacement time graph. Since this is a 1-mark question, actually that's what I'm going to do. And or we could use the velocity time graph and calculate the area under it. Now I'm not going to take that approach because I already have the distance time graph in front of me, so I'm just going to use that. So all in all, or who is this guy, whoever this is, so this went from 0 all the way to 150. Okay, now I know that it went till 100 and then it stopped for a while and then it went to 150, but it started at 0 and went all the way to 150 and then it came back. Now we're only concerned with the distance, so it went 150 meters up or whichever direction, and then it came 150 meters back. So all in all, the total distance traveled is basically equal to 150 plus 150, which is equal to 300 meters, which is the correct answer. Okay, and then we're at part B. It says the displacement x meters of a particle from a fixed point at time t seconds is given by x is equals to 6 cos 3t plus pi upon 3. Find the acceleration of the particle when t is equals to 7. Okay, so let's read it again. And first thing I'm going to do is, before I read it again, I'm going to convert my calculator into radian mode, because you can see that time given to you is in terms of pi, which means that, cos is a trigonometric function. 3t plus pi upon 3 is the angle, which is given to you in terms of pi, which basically means that you're dealing with radian mode. Okay, so now my calculator is in radian mode. I'm going to read the question again and see what exactly I have to do in order to find out what it wants me to find out. So it says here the displacement x meters of a particle from a fixed point t seconds is given by x equals to blah blah. Find the acceleration of the particle when t is equals to 2 upon 3. Okay, so let's take a step back. You're given the displacement. You want to find the acceleration. So how exactly do you use the displacement to get acceleration? Well, you don't get it instantly, but there is a 2-step process. So you first differentiate x with respect to time to get velocity, and then you differentiate velocity again with respect to time to get acceleration. Once you have your hands on acceleration, you're going to plug in this function, okay? And you're going to plug in, once you have your acceleration, you're going to plug in the value of t in the function of acceleration, and you're going to work out your acceleration. Okay, so let's start this. So let's work out dx by dt. So the derivative of cos is minus sine. So that means it's going to be minus 6 sine 3t plus pi by 3, but it doesn't end here. Then you multiply it by the differential of the angle. So differential of 3t plus pi by 3 is going to be 3. So I'm going to write this nicely before I derivate it again. So dx upon dt, which is equal to v, is basically minus 18 sine of 3t plus pi by 3. Okay, now I'm going to differentiate velocity again with respect to time so that I have my hands on acceleration. Now the derivative of sine is cos. Okay, so we're looking at minus 18 cos 3t plus pi by 3 times 3, which is equal to 18 times 3 is, I don't want to risk it, 18 times 3 is 54. Yep, so minus 54 cos 3t plus pi by 3. Now what's the value of t that we're going to plug in? We're just going to plug in 2 pi upon 3. So I'll write it over here. T is equals to 2 pi upon 3 or 2 upon 3 pi, whatever. So we're looking at minus 54 into cos and then 3 times of 2 upon 3 pi, bracket close, plus pi upon 3, bracket close. Okay, so the 3 and 3 get cancelled out. So now we're dealing with minus 54 cos of 2 pi plus pi upon 3. So let's work this out. 2 plus 1 upon 3. So first I'm just working out the fractional value, and then I'll put pi next to it. So we're looking at 7 upon 3 pi. Okay, so now I'm going to work this out in my calculator as it is. So I'm looking at minus 54 cos of 7 pi by 3. So let's see what we have. So we're looking at minus 27. So minus 27 meter per second square, and that is the correct answer. Now, one thing that I'd like to point out, had the question asked you to find the deceleration, then you wouldn't have given the negative sign, because deceleration is kind of sufficient. There's no need to put the negative sign. Just like if someone asks you, suppose you have a loss in your business, and if someone asks you that what is your loss, then you don't give that with a negative sign, because the word loss is kind of self-explanatory. And there you go, minus 27 over here is our final answer. And that brings me to the end of this question. Let's move to another question. Okay, so now we're doing question number 10, and this question, I should point out, is from May June 2021, paper 2, variant 4. Okay, and it says a particle P travels in a straight line so that its displacement, particle P travels in a straight line t seconds after passing through a fixed point O. Its displacement s meters from O is given by s is equals to 31 upon 3 minus e to the power t minus 10 e to the power minus t, and you can see that I've already underlined the word displacement. Okay, then let's see what it says. It says find the value of t, when p is at instantaneous rest, giving an answer correct to two significant figures. So you can see here we have the concept that's dealing with instantaneously at rest, which basically means that you're going to find the velocity and set it equal to 0. And when I say find the velocity, that means you have the equation of displacement. So the first thing you'll have to do is you'll have to first differentiate it so that you know exactly what you have to, so that you have the equation that you need to set equal to 0. Okay. And why exactly do I need to differentiate it? Because the derivative of displacement with respect to time is equals to velocity. Velocity, as we know, is basically speed over time. So, speed over time is what gives us velocity. Anyway, so I'm going to differentiate displacement. So 31 upon 3 is a constant, so that's going to be 0 straight away. The derivative of e to the power t upon 3 is going to be e to the power t upon 3 times 1, because the derivative of e to the power t is going to be e to the power t multiplied by the derivative of t, which is 1. And then we have minus 10 e to the power minus t multiplied by minus 1, because that's what the derivative of the power is. Okay, so let's write this nicely. So I'm just going to ignore the 0. So that means I have minus e to the power t upon 3 plus 10 e to the power minus t, and this is what velocity is equal to. And the next thing that I'm going to do is I'm going to set this equal to 0. So I'll continue from here. So I'm looking at minus e to the power t upon 3 plus 10 e to the power minus t is equals to 0. Okay. Now, how exactly should I solve this? I think I'm going to go with substitution. So I'm going to say that let e to the power t is equals to a. So that way I'm dealing with minus a upon 3 plus, now here's something I should point out, that it's 10 e to the power minus t. That means I can always write it as 10 upon e to the power positive t. Okay, so I can take the reciprocal in order to make the power positive. So that means I'm looking at minus a upon 3 plus 10 upon a equals to 0. And from this point onwards, I just need to cross multiply and solve. So, and before that, I need to take out the, actually no, I don't necessarily have to take out the LCM. I can just take minus a upon 3 over to the other side. So I'm looking at 10 upon a is equals to my positive 3 upon a now, since I've taken it over to the other side. So that means I am, no, wait a minute, I've done something wrong. Okay, so it's not going to be 3 upon a, it's going to be a upon 3. That means I'm looking at a squared is equals to 30, which means a is equals to plus minus square root of 30. Now we know that we're trying to figure out time. So time is something that's always positive, and we're not going to take minus square root of 30. We're just going to go with positive. So if you remember, we replaced e to the power t with a, so that means e to the power t is now officially equal to plus square root of 30. So if I want to work out the value of e, I'll have to apply ln to both sides. So here's what I'm looking at. So t ln e is equals to ln square root of 30. So let's work out ln of 30, square root of 30. So let's see, what do I get? So I get 1.700, and the question wanted us to give an answer correct to two significant figures, and we're getting 1.7, so that means 1.7 seconds is our final and the correct answer. Anyway, so just to give you a quick recap, we had displacement we had to find the time when this object P was instantaneously at rest. So we took the derivative of it, set it equal to 0, because the derivative of displacement is with respect to time is velocity, and whenever an object is at rest instantaneously or just like that, velocity is equal to 0. So we set it equal to 0, worked out the time, and there you go. So now we come to part 2, which says find the distance traveled in the first 2 seconds. Okay, now there are 2 ways of doing this, and I'm going to pick a certain way, and I'll also tell you the other way through which you can work this out. Okay, so one way is that I'm going to find out the distance. First thing I need to know is how many times has the object turned. Okay, now why is that important? Because this equation right here is basically giving us displacement, which is distance from the starting point. Okay, and this object is starting from O. Okay, it's we've started the stopwatch just as it passes the fixed point O. So that means when the time is 0, the displacement is equal to 0. You can find this written in the key points also above. Okay, and the thing is, the reason why I can't just plug in 2 in this equation and give that as my final answer, and I'm sure, although I hope I'm wrong, that some of the students must have done this. Actually, this paper got cancelled, so I'm pretty sure no student did that. But this is a very common error, that you have the equation of displacement. Students just tend to plug in the value and find out the displacement and give that as the final answer. Now, one thing I should mention is that for as long as the object doesn't turn, the displacement and the distance are the same. But the second the object turns, the displacement and the distance are 2 different values. Okay, you're going to get 2 different values for both. Now, when we set our velocity equals to 0, we got t is equals to 1.7. Now, why is that important? Now, remember, there is a rule that whenever the velocity is equal to 0, from that point onwards, the object travels in the opposite direction. Or the object, whenever the velocity is equals to 0, it is because the object has turned. Okay, so what I need to do now is I need to break this journey down. So here, right here is the starting point. Okay, so this right here is the starting point. Okay, I'm going to call this O. Now, for as long as t is equals to 1.7 seconds, our object is traveling in a straight in a single direction. Okay, so this is t is equals to 1.7 seconds. Okay, and I need to know what distance it covers, or how far off it is from the starting point when t is equals to 1.7. So of course I'm going to have to use the equation of displacement, which is 31 upon 3 minus e to the power t upon 3 minus 10 e to the power minus t. Let me just make sure I've copied it down correctly. Yep, I have. Okay, so now all I'm going to do is, in place of t, I'm going to plug in 1.7. Okay, and I want you guys to do the same. So if I plug in 1.7 in place of t, so I'm looking at t is equals to 1.7, s is equals to 6.6818. Okay, so since this is not my final answer, you can see that I am taking more than 2 significant or 3 significant figures, so 6.6818. Okay, once we get to the final answer, we'll give it correct to 3 significant figures. Okay, now what does this mean? This basically means that from 0 to t equals to 1.7, this particular object is 6.6818 meters from the starting point. Now at t equals to 1.7, the object turns, okay, and then we just need to find out how far it travels in 2 seconds, okay, or what is the total distance traveled in 2 seconds. Now that I know how far the object is from the starting point at t is equals to 1.7 seconds, now what I need to do is I need to find out how far the object is from the starting point at t is equals to 2 seconds. So all I'm going to do is, wherever I plugged in 1.7, I'm going to replace that by 2. Now the value that I get now is 6.5169. Okay, now how exactly are we going to work with this now? So at t equals to 2 seconds, or I'll just write 2 so that you don't confuse the s of seconds with the s of displacement. The displacement is 6.5196 and so on and so forth. Okay, now what does this mean? This means that at t is equals to 2 seconds, our object was 6.5196 meters from the starting point. Now remember, students, what we have to work out is the total distance. Okay, so first, let me explain what I mean by that, or what the question means by total distance. So the total distance is basically this distance, the distance traveled from t equals to 0 to t equals to 1.7, and then the distance traveled from t equals to 1.7 to t equals to 1.2. Okay, so in simple terms, it's basically the length of this line and the length of this line. Okay, now as far as the length of this line is concerned, where I'm making this arrow, it's pretty straightforward. It's going to be 6.818. sorry, 6.6818. Yeah, my bad. 6.6818. And then as far as the length of this line is concerned, where I've made the other arrow, this can be worked out by taking the difference of 6.6818 and 6.5196. Okay, and that's exactly what I'm going to do in my calculator now. Oops, sorry about that. To find out the total distance traveled. So 6.6818 plus, bracket open, 6.6818 minus 6.5196. Close the bracket, press the equals to sign, wait for the magic. So now we have 6.844, which if we log to 6.84, it falls inside the acceptable range. And this right here is our final and the correct answer. So I hope you guys have understood that. So now we come to part B of the same question, and this says a particle Q travels in a straight line so that t seconds after leaving a fixed point O, its velocity v meters per second is given by. Now the velocity is equal to 2t for 0 to 5. So that means for as long as time is between 0 and 5, the velocity is equal to 2t. So we can work out the value of velocity by plugging in values 0 to 5. Okay, you can think of this way, that for as long as t is between 0 to 5, this is the velocity function. And for as long as t is greater than 5, this is the velocity function. Okay, so we're going to draw this graph in two parts. So the first graph that I'm going to draw, again, I'm going to try and color code it. So I'm highlighting this blue, and I'm going to draw it in blue also. So 2t basically means that we're looking at a straight line. Okay, and all I got to do is just plug in the endpoint. So if I plug in 0 in place of t, I get velocity equals to 0. And if I plug in 5 in place of t, so 2 times 5 is 10. And plugging in 5 means that I get 10. So I'm looking at a straight line that runs from 0 all the way to 10. And there you go. This is what it looks like. Okay, you can, what I've done here is, I should elaborate, is that I've just plugged in values. Okay, so if you plug in 0 in place of t, you get 0. If you plug in 1, you get 2. If you plug in 2, you get 4. And just like that, 6, 8, and then all the way to 10. Now from 5 onwards, we have a quadratic curve, which is t squared minus 8t plus 25. Okay, now how exactly are we going to make this? Let's see, if I plug in 5 in this, so let's see, although it should be equal to 10, but just to be on the safe side, let's see what do we have. So I am looking at 5 squared minus 8 times 5 plus 25. It is equal to 10, as I mentioned. So what I'm going to do now is, since I have to go all the way to 8, so I'm going to plug in 6 in place of time so that I have the corresponding velocity. So at 6, the velocity equals to 13. Okay, so that means it's going to be somewhere over here. Sorry, it's going to be above this. And then I'm going to plug in 7 in place of time so that I have the corresponding velocity. So I have 18, which is going to be somewhere over here. And then finally, I'm going to plug in 8 in the equation of the curve in place of time so that I have the corresponding velocity, which is, let's find out, so 8 squared. So that's 25. So that means it ends at 25. So we're looking at a quadratic curve. And again, let me color code it for you guys. So I'm going to highlight this red, and I'm going to draw the final curve in red also. So this is what you're looking at. And there you go. You got 2 marks for this. So not exactly difficult marks to get. Show all your working, find the distance traveled by Q in the first 8 seconds of its motion. Okay, so this is a 5-mark question, and we need to have a very systematic approach behind this. So our travel graph or velocity time graph is divided into 2 parts. One is the straight line. Okay, so we can work out. Okay, so first of all, we need to find out the area under it. Why? Because you need to find the distance. You're looking at a velocity time graph. So first thing you need to know, you need to realize is that if you work out the area of this, you can calculate the distance because it's a velocity time graph. So that means I need to find out the area. Now, in order to find out the area, I'm going to have to break this graph. So first, I'm going to consider this region, which is under the straight line, which is basically a triangle. Okay, so I'm going to work this out. So area of a triangle is equal to half times base times height. So the base is 5, as you can see. The height is 10, again, as you can see here. Okay, so we're looking at half times 5 times 10, so that's 25 meters. We could have also integrated the line 2t, but no point. That would have made things more difficult. Since it's a straight line, you can very easily work out the area. Now, however, we're not left with an option. We have to integrate the equation of velocity of the curve that I have drawn in red, t square minus 8t plus 25 with respect to time. So t square minus 8t plus 25 Is it 25? Yeah, it's 25 with respect to time. So dt within the limits 8 and 5. Okay, so basically you need to be careful when you're integrating it. You need to be careful when you're plugging in values, and yeah, long story short, just be careful. Okay, so the integral of t square is going to be t cube upon 3 minus 8t square upon 2 plus 25t within the limits 8 and 5. Okay, so one by one I'm going to plug in the limits. So we have 8 cube upon 3 minus 8 into 8 squared upon 2 plus 25 times 8. And remember, whenever you're integrating within limits, then you don't put a plus c because it just gets cancelled out even if you do. And then you're looking at 5 cube upon 3 minus 8 into 5 squared upon 2. I should have simplified this, but anyway, it's okay. Plus 25 times 5. All right, so let's work this out one by one. So the cube of 8 is 512. So we're looking at 512 upon 3 minus again 512 upon 2 plus 25 times 8, which is 200. Yep, it's 200. Okay, we'll work this out in the next step. Minus 125 upon 3. 5 squared is 25. 25 times 8 is 200. We just worked it out. 200 upon 2 plus 25 times 5, which is 125. Okay, so let's work this out one by one. So 512 divided by 3 minus 512 upon 2 plus 200. So this is equal to 344 upon 3, and from it let's subtract this. So we're looking at 125 upon 3 minus 200 upon 2, which is just 100. So I'm going to write it as that, plus 125. So we're looking at 200 upon 3. Okay, so this turns out to be 344 minus 200 is equal to 144. Dividing it by 3 is equals to 48. So that basically means that the area under the red graph is equal to 48. Okay, so I should have highlighted this red for you guys. So there you go. Okay, so now all you got to do is you just got to sum them up. So when I do that, let's see what do I get. So I'm going to switch to a neutral color. So 25 plus 48. Let's see what is that equal to. So 25 plus 48. So we're looking at 73 meters, which is the correct and the final answer. Okay. So that brings me to the end of this question, and let's move over to the next question and see what do we have. Okay, so now we're going to solve another question, and this is a question from May-June 2021, paper 2, variant 2, and it's question number 8. It says here a particle moves in a straight line so that t seconds after passing through a fixed point O, its velocity v meters per second is given by v equals to 3t squared plus minus 30t plus 30t plus 72. Find the distance between the particle's two positions of instantaneous rest. Okay, so there's a lot going on in this question, okay, and a lot of important concepts that I'm going to highlight and point out as I'm solving this question. So it says find the distance between the particle's two positions of instantaneous rest. Okay, so whenever we see the word instantaneous rest, or just rest for that matter, that should instantly tell us that the velocity is equals to 0. Okay, so that's what I'm going to do. I'm going to set the velocity equals to 0. So I'm looking at 3t square minus 30t plus 72 is equal to 0. All right, and then I'm going to solve this equation. So first thing that I should do is I should probably divide this equation by 2. That's going to make life slightly easy. So 72 divided by 3 is 24. So plus 24 equals to 0. So we can do this with the help of middle term breaking, and we're going to get t square minus 6t minus 4t plus 24 equals to 0. Now let's factor out t. So we have t minus 6. And then let's factor out minus 4. So we have t minus 6 again. So now we're looking at t minus 4 times t minus 6 equals to 0. That means t is equals to 4 or t is equals to 6. Okay, so now we just have the two values of t where the particle comes to rest instantaneously. Okay, now what do we have to do? We have to find out the distance between these two positions. Okay, so the first thing I should emphasize on is that we need to visualize what exactly is going on over here. So here is the starting point O, and the object comes to rest when t is equals to 4. Okay, so now what I would like to do is I would like to find out how far off this object is from the starting point when t is equals to 4. So we have the equation of velocity, and we need to find out the displacement, which means that we need to integrate velocity with respect to time. Now bear in mind, this object is starting from O. That means at t is equals to 0, the displacement will be equal to 0. Okay, so I'm going to integrate velocity with respect to time. So that's going to give me s. So now we need to integrate velocity with respect to time. So let's write down the equation for velocity that we have. So we have 3t square minus 30t plus 72, and this is what we need to integrate with respect to time. So we have 3t cube upon 3 minus 30t square upon 2 plus 72t. Now I am going to write plus c because that's what we normally do whenever we're integrating it. But over here, c is going to be equal to 0. Why is that? Because the object is starting from O, okay? And whenever the object is starting from O, at t is equals to 0, the displacement is equal to 0, okay? So, and whenever the object is starting from O, what you need to remember is that t is equals to 0, displacement is equals to 0. Even if you plug that in over here, you will get c is equals to 0, right? Let me show you what I mean in just a minute. So s is equals to t cube minus 10 or minus 15t square. So minus 15t square plus 72t plus c. So if I plug in t is equals to 0, so everything becomes 0. So 0 cube is 0, minus 15 into 0 square is 0, 72 times 0 is going to be 0, and s is also equal to 0. So that means there's no need to write plus c here. I can just, cross it out. Okay, so now that I have s, or displacement, so the next thing that I'm going to do is I'm going to plug in 4 in place of t. So when you plug in 4 in place of t in the equation of displacement, what you end up with is, let's find out, so 4 cube minus 15 times 4 squared plus 72 times 4. So you end up with 112. So that means at t is equals to 4, the object is 112 meters from the starting point. Yep, I should write meters here. And then you plug in 6 in place of t. So when you do that, let's see what you have. So if you plug in 6 in place of t, so you get 108. Okay, now let's see what this basically means. Let's see what these two distances basically mean. Now at t is equals to 6, the object is 108 meters away from the starting point. Okay, now what exactly do we need to find out? We need to find out this distance, because that's what the question says. Find the distance between the particles' two positions of instantaneous rest. Okay, so from this point, it shouldn't be that difficult. So all you got to do is you got to find out the length of the longer line, which is basically this 112, and from it you got to subtract 108. So if I do that, I get, oops, sorry, let me switch to the regular pen. 112 minus 108 is equals to 4 meters. Yep. So what is the distance between the particles' two positions of instantaneous rest? The answer is 4 meters. Okay. Now the question says find the acceleration of the particle when t is equals to 2. So we have, initially we were given the velocity. So let me write down the equation of velocity. So it's 3t square minus 30t plus 72, and we need to find out the acceleration. So how do you get velocity when you're given acceleration? You differentiate velocity with respect to time. So you're looking at 6t minus 30, and then what you're gonna do is you're gonna plug in 2 in place of t. Okay, so if you plug in 2 in place of t, here's what you get: 6 times 2 minus 30. So a is equals to 12 minus 30, and 12 minus 30 is equal to minus 18, just to be on the safe side. 12 minus 30 is equals to minus 18 meter per second squared, because that's what the unit of acceleration is. Okay, so that brings me to the end of the question and also to the end of this video. I hope you guys have a good grip on kinematics. I will encourage you guys to attempt the other questions that I have. I will make a follow-up video on this where I solve the remaining questions. Not all of them, but yeah, quite a few of them. And again, if you have any questions that you want me to solve, you can reach out to me on Instagram and let me know. So yeah, take care of yourself. I hope you guys are preparing for your exams. I'll see you guys in the next video. Until then, take care. Bye-bye.